Hello and welcome to Data Engineering with Subhadip. In today's tutorial, we are going to dive deep into SQL Query Execution Plans. We will learn how to read and understand them to make our queries faster and more efficient. So what exactly is a query execution plan? Think of it as a roadmap. When you submit a SQL query, the database optimizer creates a plan outlining the most efficient way to access and process the data. This plan is our key to understanding and fixing performance bottlenecks. Our first tool is the explain command. When you place explain before your query, the database simply returns the plan it intends to use without actually running it. This gives you a quick look into the optimizer's brain, showing you the estimated steps and costs. To get the real story, we use explain analyze. This command first executes the query and then returns the plan along with actual performance metrics, like how long each step took and how many rows were processed. This is incredibly powerful, but be careful using it on slow queries in a live production environment. Execution plans are made up of several key components. Each step is a node or operation which tells you what the database is doing. The cost is the optimizer's guess of how much work is involved. Estimated rows is its prediction of the data size. And with analyze, you get the actual time in rows, which is the ground truth. The first step in any query is accessing the data, and this is done through a scan. A sequential scan or full table scan reads every row, which can be very slow. A much better alternative for large tables is an index scan, which uses an index to quickly pinpoint the exact data you need. Next up are joins, which combine data from multiple tables. The database has several strategies. A nested loop join is simple but often slow. A hash join is generally the workhorse for large datasets, building an in-memory hash table for fast lookups. And a merge join is highly efficient when both tables are already sorted on the join key. After accessing and joining data, we refine it. The filter operation removes rows that don't match your where clause. A key optimization principle is to filter early, reducing the amount of data later steps have to process. The aggregate operation then performs calculations on grouped data, like counting or summing values. Alright, let's put it all together with a practical example in PostgreSQL. This query counts the number of high-earning employees in each department. It involves a join, a filter, and an aggregation. Now let's see what the execution plan for this query looks like. Here is a simplified view of the plan. The key is to read it from the bottom up, or from the most indented part outwards. First, the database performs a sequential scan on the employees table, applying the salary filter. It also scans the departments table. Then it performs a hash join to combine them, and finally it aggregates the results to get the count. Modern cloud warehouses offer more visual tools. In Snowflake, you can run the explain command, but the real power is in its query profile UI. It provides a rich interactive graph of the execution plan, making it easier to spot issues like long-running table scans or data spillage to disk. Similarly, Google BigQuery integrates execution details directly into its console. After running a query, you can view the execution graph, which shows how the work was distributed across different stages. You can analyze how much time and resources each stage consumed, which is key to optimizing queries in its distributed environment. So to recap, here are the key takeaways. For any slow query, start with explain analyze. Pay close attention to differences between estimated and actual row counts, as this can signal a problem. Be critical of full table scans on large tables, and always think about how you can filter data earlier in the process to reduce the workload. And that wraps up our visual guide to SQL Query Execution Plans. I hope you found this tutorial helpful. If you did, please give this video a thumbs up, share it with your colleagues, and subscribe to Data Engineering with Subhadip for more content. Thanks for watching, and happy coding.